Fanola 687 AU, 1957–1958. This video is informational and not entertaining. This table of contents could guide you through the available topics. This radio was built during the years 1957–1958 by FIMI at Sarano Varese, Italy. The advert found in a magazine published in 1961 shows a model that is similar to this radio. There are a few variants of this radio with the model number 687, but also significant differences in the schematics. This radio model was capable of receiving the broadcast band, some shortwave FM, and some television audio channels. However, today, due to the changes in the transmission technology, that analog television band is useless. Being a radio that can receive such different bands, the switching system between bands and modulation is quite complex, making the interpretation of the schematic diagram and servicing the radio a demanding task. Luckily, this radio uses a printed circuit board, which at least reduces the troubles when the servicing is not related to the high-frequency modules. The radio is still capable of working, and only the replacement of questionable components that are easily reachable is planned. As already mentioned, this radio model has different variants, each with significant differences in the schematic diagram. Even if the goal is only to replace some components, the schematic diagram is necessary in case it were impossible to read the value that they are supposed to have. This is the original schematic diagram available online, with a few additional annotations based on the experience on the radio that is checked. The original schematic diagram reports the expected voltages between those points and the chassis, showing two different values. The upper values are meant to be found if FM or TV is selected, while the lower values are referred to medium wave or short wave. Please notice that the selection of FM or TV activates the same group of switches in the main switching module, and only a remote group of switches makes the difference in the two selections. One can see that pressing the TV button pulls the remote switch under the VHF or UHF section of the chassis. However, the TV band has two sub-bands, high and low, and one of them must be preselected from under the chassis. One thing that should be checked with tube radios made in the 1950s and in the 1960s is the possible deterioration of capacitors inside the IF transformers. That would be called silver mica disease. In this radio, the IF transformers are easily inspectable, removing a couple of screws under the printed circuit. Luckily, these IF transformers use regular coated capacitors, for which there is no reason for concern. While under the chassis, the printed circuit is relatively clean. The top of the printed circuit, with all the components, is covered by dust and grease. It is necessary to clean that coat of dirt, and some alcohol is used for the purpose. However, most of the resistors appear to lose their color code with alcohol or any other mild detergent. Even though the value of most resistors is still in tolerance, as they have discolored, or they are going to discolor while cleaning, all the reachable resistors will be replaced. The cleaning process will progress slowly while changing the components. Printed circuits are always delicate in relation to the applied heat necessary for soldering. While the soldering process is relatively easy and fast, usually desoldering requires more effort and more attention to avoid ruining the copper traces. It is probably better to cut the component that is to be replaced, remove the old tin with a desoldering bride, push the terminals out, freeing the holes. The new component could then be installed very easily. This boring clip shows the process for the replacement of a single component. So far, the component has been cut, while the removal of tin and residual terminals is still ongoing. This radio uses a selenium rectifier made by Siemens. This is replaced with a silicon diode FR207. While replacing the selenium rectifier, also a resistor could be added to maintain the voltage differential and control current surges. However, in this case, a different solution is used, which will be described later. It is unclear the function of the capacitor in parallel with the rectifier. Maybe it is meaningful only for that type of selenium rectifier. Anyhow, this capacitor, which is also clearly destroyed, will be replaced with a security capacitor. The original schematic diagram mentions that this should be a polyester type. But the real original one seems to be only a paper capacitor. While testing, using an insulation transformer and a dim bulb, the radio shows that it is able to function properly at just about 160 volts AC instead of 220, when the filaments would receive only around 4.5 volts AC. As this reduced filament voltage would increase the life of the vacuum tubes, instead of the resistor replacing the differential voltage of a selenium rectifier, a small light bulb is integrated in the radio with the function of current regulator. Consequently, all voltages that would be found in the radio circuit might be lower than what annotated in the original schematic diagram. This video clip shows what happens when the radio is turned on with this integrated light bulb. Another important adaptation is related to the antenna input for medium and short wave reception. The original schematic diagram only considers the possibility of a wire antenna, while it is important to be able to connect a loop antenna, which would also require a connection to the chassis ground. The chassis ground is connected to the mains. Therefore, two decoupling security capacitors are needed. While cleaning and working on the printed circuit board, the trimmer or 37 might be disturbed. Its function is to balance the detection of the frequency modulated signal. It should be adjusted to obtain the right quality of sound while receiving FM stations. At the beginning of the refurbishing process, the dial cord is still operational, even though it is a little loose. While working around the chassis, the dial cord becomes looser and trying to tighten it, it breaks. So it is necessary to study the dial cord arrangement, which appears to be unusual and interesting. The dial cord is not anchored to the variable capacitor pulley. Only the tension of the spring keeps it in place. Some thick fishing wire is used with success. The cabinet has two things to be taken care of. One foot is detached and the bottom shield, made of aluminum foil, should be replaced. First, the aluminum foil is removed. In fact, it was originally a sheet of paper with aluminum foil glued on top of it. The same thing is reproduced with a thick sheet of paper, glue, and aluminum foil. Before proceeding with it, the detached foot is checked. Originally it was attached to the cabinet, melting a portion of the plasticate in the corresponding cabinet hole. The foot is attached again with a small screw. It is important to consider that screw might get in touch with the aluminum foil inside the cabinet, which in turn would be connected to the chassis. This means that the foot screw must be insulated after installing the foot again. In this case, it will be covered with hot glue later. The sheet of paper and aluminum foil is then cut to the needed size and glued inside the bottom of the cabinet, paying attention to avoiding the risk of electrocution. In particular, it should not be reachable from outside the cabinet, neither directly nor indirectly touching metal objects that are exposed from outside. For example, at the bottom of the cabinet there is a metal plate that is used to cover a hole which would allow access to the TV sub-bands selection. The screws holding the plate to the cabinet will be replaced with nylon screws to make sure that there will be no contact with the internal aluminum foil. This radio, like other radios produced in particular in the 1950s in Europe, by design has some security issues that no type of restoration could solve, which normally one would not think about. The first dangerous thing to take care of, and to keep in mind, is the risk of electrocution. The radio chassis, and consequently all metal parts contained in the radio, are connected directly to the mains. Even when the radio is turned off, but still connected to the mains, getting in touch with any metal part of the radio would imply an electrocution. The typical dangerous situation that could happen is that a knob comes off and one might be tempted to put it back on the metal shaft. However, if the radio is still plugged to the wall socket and the shaft is touched during this maneuver, one would be electrocuted. For the same reason, operating the radio with wet hands might be dangerous. If the water gets in touch with the volume or tuning shaft, the operator would be electrocuted. Another group of accidents might occur because vacuum tube radios are like little ovens. When the radio is contained in a metal case, the risks related to the working temperature are perceived because the case becomes warm or even hot. But when the radio is contained in a wooden or plastic case, this problem is usually ignored. For something that is like a little oven, the place in which it is used is important. For example, one would not want to use a tube radio near flammable objects, including curtains. But for the same reason, a radio like this one should not be left playing without anybody around, keeping a minimal control at it. Due to the small size of the cabinet, on extreme occasions, even the wood case could catch fire. So please think about it and take care. What you see and hear is a reception test done in the early evening with an indoor loop antenna connected via coaxial cable to the new antenna port added. Please notice that at the time of this test, the dial indicator was attached to the wrong side of the dial cord, moving in the opposite direction of what it should. This mistake would be corrected later.
La dolce vita, vuoi nuotare? XVIII monastero
primario.
The test starts with the FM band, which for this radio is between 85 and 102 megahertz.
Fabbrica.
The test continues with the medium wave band between 530 and 1570 kilohertz, about 570 and 190 meters. This band is mostly affected by electrical noise produced in the whole neighborhood.
Fiamme anche in Grecia, i grandi roghi nel...
Shortwave band between 6 and 11 megahertz, about 51 and 28 meters.
セカンドアルバム「天の守護神」からシングルカットされ
There is nothing that could be received in the television band. This video comes with written documentation available from the links appearing in the description under the Show More tab. One may find files corresponding to individual chapters with the topics of interest, or a large single file with the whole work, which however is updated less frequently. The written documentation is meant to support the videos with updates, references, more detailed and better resolution pictures. The written documentation also covers annotations regarding failed projects and other stuff that doesn't have a corresponding video.